Hello CS50, I'm George Newman, I'm 18 and I'm from London, England, and my final project was to make a fractal renderer on my CG50 graphical calculator. Now, I have a lot to cover, so let's dive straight in. Now first of all, why did I want to do this? Well, I am a maths lover, and what better way to showcase the beauty of mathematics than rendering a Mandelbrot set on an instrument I use every day when I'm doing maths, my calculator. You can see the formulas that I've used and the maths behind this renderer down in the bottom right, but for the time being we're going to skip over that straight into how you actually use the program. So, after you've compiled your code and imported it onto your calculator, at the bottom of the main menu screen there should be a new app called Fractals, which when selected should highlight cyan. When you click on this, you should then be brought to this settings screen, where you can either press F6 to go to the program settings, which I'm not going to cover here, or you can press F1, which will begin rendering the Mandelbrot set. In the top right, you can see a simple black and white Mandelbrot set that was my first prototype. And my first upgrade to this was to make it so that the colour of the halo surrounding the set changed depending on the number of iterations required for the complex number at that point to pass the critical boundary and spiral off to infinity. Lighter meant more, darker meant fewer. However, I really didn't like the solid colours surrounding the halo, so I used the following commands to override the display's typical limit to 3-bit colour and upgrade to 16-bit colour so that I could use the full RGB 565 spectrum and get a nice gradient, which looks a lot prettier. My next upgrade to the prototype was to make it so that it rendered in real time, creating a really nice scanline effect going from the top of the screen to the bottom of the screen. I used the following commands to not only write to the VRAM but also force it to the display, which created this amazing effect. Next up, I made a function that would draw a real and imaginary axis onto the complex plane that the Mandelbrot set resided in, so that then you can get a sense of scale. Lastly, I implemented my favourite function, the trace function. This works by using the arrow keys on the calculator to move a red cursor around the set. By then pressing the execute button, you can select a complex number and it will draw the path that that complex number takes as the iterative formula is applied to it. This creates some amazing shapes, stars, lines. Some of them are a bit of a mess if they're outside of the set, but it really shows how the iterative formula is applied visually. You can see this by the fact that any time you select a complex number inside the set, it will always spiral down and converge at a point, whereas if you select somewhere outside of the set, the trace will always spiral off to infinity. Overall, this is definitely one of the hardest programming challenges I've ever set myself. The calculator's functions are very, very poorly documented, and having to constantly write to the VRAM in order to render something to the display made life very tricky. However, I thoroughly enjoyed the challenge and would definitely like to upgrade this in the future. So that's been my CS50 final project. Thank you so much for watching.